I just want to start off before introducing the members of the panel by telling you that when we first talked about this panel discussion, the idea was we have a broad audience. We know that we have people with a lot of different specialties in terms of their interests, and most people listening to this probably don't have too much experience with stream restoration. So this is really a broad overview. It's not intended that you walk away from this knowing everything there is to know about restoration design. It's really more to give a sense as to what is the role of stream restoration in the overall Bay watershed restoration effort, and what are some of the issues that we have to consider in thinking about what role stream restoration plays and how we know whether it's working. So without further ado, I'm going to go ahead and introduce the members of the panel. Solange Filoso is Associate Research Professor at the University of Maryland's Chesapeake Biological Lab. Her background is in ecosystem ecology and biogeochemistry with a focus on freshwater ecosystems. Her current research seeks to understand the effects of human-accelerated environmental changes on functional capacity of streams and wetlands, and whether and how management practices such as ecological restoration can help to mitigate such impacts. And I actually have to convey apologies from Solange, who, because of a family issue that she needs to work on today, is not going to be physically present for this discussion. I have consulted with her extensively, and so when it comes time for some answers to be provided, I have her answers, and I will actually stand in for her at that point. Dave Goerman is Water Route Program Specialist in the Division of Wetlands at the Pennsylvania Department of Environmental Protection. He is responsible for providing permitting and technical expertise on a wide range of issues involving waterways, wetlands, floodplains, and stormwater management. His recent work is focused on aquatic ecosystem restoration, compensation, and resource assessment development. Tom Jordan is a senior scientist at the Smithsonian Environmental Research Center. Since starting at CERC in 1980, Tom has studied the sources of nutrient releases from watersheds, the uptake of nutrients by wetlands and riparian forests, and the fates and effects of nutrients in estuaries, especially in Chesapeake Bay and its watershed. Scott Lowe is Director of Environmental Services at McCormick Taylor, with over 25 years of experience in all aspects of environmental design and permitting services for projects throughout the Mid-Atlantic. He's recently helped to develop TMDL crediting procedures and restoration design guidance for stream restoration and outfall restoration projects for watershed implementation plan projects in the Chesapeake Bay watershed. Tess Thompson is an Associate Professor in Biological Systems Engineering at Virginia Tech. She has worked as an engineer in state government and private consulting, and as a consultant to the U.S. Agency for International Development. Her research focuses on stream and wetland restoration, urban stream systems, and stream bank erosion. So I'm going to start with just a quick overview of the 5 questions that we've posed, and then I'll explain how this is going to work. Here are our questions. What are the most common drivers and goals of stream restoration? What do we mean by stream restoration, and what are some common actions taken as part of a restoration project? What are realistic expectations for a restoration project? How does stream restoration fit into a watershed management plan? And how do you evaluate whether it worked? How do you define success? And how long does it take in order to know the answer to that question? So for the first 2 questions, I'm going to give a short presentation that's based on a summation of some conversations that I've had with the panel in order to try to put some common information out there. And I'm going to show some slides with illustrations of examples of restoration projects selected from examples that were sent to me by members of the panel. And when we get done with that short presentation, then I'm going to open it up for panel members if they want to augment or correct anything that I have said. And then we'll move on to those last 3 questions. And we're going to try to leave some time at the end for questions and answers. So what are the drivers? The drivers are the things that actually motivate going into a restoration project. So typically there are 2 classes of drivers: the need to mitigate a watershed scale problem, or the need to respond to a local reach scale problem within a watershed. So, TMDL load allocations for control of sediments and nutrients would be an example. MS4 permits to control urban runoff. And sometimes we'll have comprehensive watershed management plans with multiple project components that are designed for local or state purposes that may not be strictly governed by the TMDL. Then you have local reach scale problems: property damage, hazard to residents, threatening of infrastructure, pollution of local waters, degradation of habitat, and impact on living resources. So those are the kinds of things that motivate projects. But what about the goals? So the goals can include a range of things: retention and reduction of nutrient and sediment loads to receiving waters, stabilization of stream bed and banks, mitigation of stormwater that causes erosion and flooding, reconnecting the stream channel to the floodplain and the riparian zone, restoring groundwater surface water exchange, attenuation of floodwaves and reduction of inundation depth and extent, mitigation of excessive heat loads, particularly in urban environments, rehabilitation of habitats suitable for colonization by native populations. That's not a complete list, but that's a reasonable list, I guess I would say. And often the collected set of goals are characterized under the broad rubric of what we refer to as functional uplift. It's important to point out not every project has all these goals, and not every project that has multiple goals attains all of them, and that we'll get into later when we talk about the question of what are realistic expectations and how do you know whether it's working. What do we mean by stream restoration? So I've compiled this definition. We'll let others on the panel modify it as they desire, but the wording here is that it's an intervention or modification of the stream channel and or the riparian zone, including substrate and vegetation community. It's intended to rehabilitate or restore ecosystem functions that have been degraded as a consequence of human activities that alter natural cycling of water, sediment, nutrients, and contaminants. And there are a number of common practices, and I'll show you some illustration of some of these. And they include things like raising the bed of the stream or lowering the adjacent riparian surface in order to reconnect the channel with the adjacent surface, setback of channel banks, planting of riparian vegetation, installation of structures to absorb or dissipate or redirect stream power, and sometimes this involves total reconfiguration of the channel riparian zone rather than just one or two of these things. There are multiple design approaches with different kinds of guiding principles. There's an immense literature on evaluation of whether restoration works and different strategies. We're not going to really have time to get into all of that literature. This is really just to give an overview of the context of the Chesapeake Bay Watershed, but it's important to recognize that this is the case. So I'm going to start with some slides and some examples, and I'm going to go through these pretty quickly just to illustrate for you some examples. This is a slide from Solange. Filoso, she's done some work on both headwater and lowland environments at the mouth of the watershed and at the head of the watershed, headland gully channels and some lowland stream channels where one solution has been attempted is to do lowland wetland complex restorations. So here's an incised gully, pre and post restoration. Here's a lowland stream, pre and post restoration. And I'll have another slide from Solange later when we get to answering some of the questions. These are some slides from Dave Goerman. I'm just going to go quickly through. He's got slides that represent different kinds of watershed sites. Here you have a hillside seep or head cut in a first order or zero order stream, pre-restoration, post-restoration. Here you have a headwater stream, but a little bit farther downstream, a narrow valley, deeply incised, pre-restoration, post-restoration. And as you move on downstream, a somewhat wider valley with high banks, over-widened, pre-restoration, post-restoration example. As you get farther downstream, in mid-reach streams, it's particularly common to see streams that have high banks. Many banks in the Mid-Atlantic are underlain by legacy sediments, historical aggregation of sediment produced from upland erosion, sometimes trapped behind mill dams, sometimes there for other reasons. And so some projects actually attempt to restore these through a variety of means. This is an example from a larger drainage area site, again in Pennsylvania, showing you pre and post-restoration conditions. This is an example from Virginia Tech. This is an urban restoration project. It is not an urban site, but this stream, which is a project that was developed on the campus of Virginia Tech, was actually designed to mitigate the effects from upstream stormwater coming out of Blacksburg and affecting conditions at the site. So this is, I'm just going to show you a sequence of slides over time. This is pre-construction, during construction, 2 years post-construction, 5 years post-construction, and 8 years post-construction. We may be returning to some of these examples as individual panelists may ask me to pull up one of those slides. This is an example provided by Tom Jordan, whom you can see in that picture there, standing next to an extremely high stream bank on Muddy Creek in Anne Arundel County. This is a regenerative stormwater conveyance project. You can see during construction raising the bed of the channel to reconnect it with the adjacent surface. This shows you a pool that's been restored in Muddy Creek. This shows you a riffle that's been restored in Muddy Creek. I've thrown in a couple of text slides from Scott Lowe. I'm not going to go through the details of all of these, but I'm simply using this one to illustrate that there are a series of steps involved in design and assessment of what needs to be done, then coming through to pre-construction services, construction services, the actual implementation of the project and monitoring, and along the way, various steps in planning, public outreach, coordination with agencies, and permitting, which is often a rate limiting step in getting anything built. And this just illustrates some of the scientific input that's needed, both for the design as well as for modeling and testing whether you think something's going to work, as well as in, monitoring for the results, aquatic ecology, chemistry, and botany. And some of the questions that Scott, this is from one of his other presentations, linking design goals, implementation strategies, trying to figure out whether there's actually a way to get a result that's going to work, identifying constraints and opportunities, and implementing multidisciplinary approaches. You saw some of those disciplines on the previous slide. This is just an illustration of an example of a site where Land Studies did a restoration. This was a legacy sediment removal project. There you see the pre-restoration. There you see first year after restoration. Here's a site that was designed by McCormick Taylor for Baltimore County in the North Fork of White Marsh Run, an incised and widened channel. There you see the first year after restoration. There you see some vegetation starting to encroach in the second year after restoration. And the last example I'll show you is from a tributary of Dead Run that is located in the outskirts of Baltimore. There's the Baltimore Beltway. It's highly incised set of gullies that were there until the restoration project was put in as a result of urban runoff. This is what it looked like in 2018, shortly after the project was completed. There never really was a natural riparian zone here, but they did a setback in order to create one. This is what it looked like shortly after the project was completed. This is what it looked like about a year later. It actually survived a pretty big flood with only a modest amount of damage. I should point out that I'm showing you look like relatively successful examples. This does not mean that all restoration projects are successful. I'm sure I'll have an opportunity to talk about that as well. Okay, so with that covered, I want to now start to talk about the questions again, and I'm going to start by saying here are the first two questions, and I'm going to stop sharing the screen so I can control the ability of different panelists to respond. I'm just going to ask if any of the panelists want to say anything with regard to any of those questions. I'm going to actually unmute our panelists. Actually, I don't know how to unmute them. Shirley, can you unmute them? Oh, okay, that worked. Or maybe you can unmute yourselves.
Andy, they can unmute themselves.
Okay, fine. So if you can all unmute yourselves, then I'll just take, if anybody want to add to that before we go on to the other questions.
No, thank you, Andy. I think you did a great job. This is Dave.
Thanks. Does anybody want to add, or should we go on to the next question?
Andy, there's a question with regard, I don't know if you want to take questions now or later. There was a question regarding RSCs.
Well, let's get through the presentation and take Q&A afterward, I think. So right now I'm just looking for, I'm sorry, Tom?
No, I don't have anything.
Okay. All right, so I'm going to go to the next question. Tess.
Yeah, Tom, I really like your point that I think context or scale is really important. So where are you in the landscape and what type of systems do you expect to see there. But I also think from a very realistic standpoint, we do stream restoration on parcels of land. And so ideally, we would look at the entire watershed as a whole. We don't, because of land ownership and how these are funded, we can't do that. And so it is something of a piecemeal process. And so that does limit what we can achieve with any individual project. And again, you can't really disconnect the stream from the watershed. And so there's only so much that can be done on a limited parcel of land. You know, it's a step forward in a very long process, but a single stream restoration project isn't going to fix all of the water quality issues that are coming from the surrounding watershed. So it's really part of a puzzle. And something else, and Scott kind of alluded to this, is the stream is entering your project. You really can't control what's coming from upstream. So you can only design around the situation that you actually have. And so that will limit, you know, depending on water quality, what type of ecosystem that you can restore, depending on how large the parcel is, where the most adjacent buildings and infrastructure is, will limit the width of the floodplain if you're going to create a floodplain. So these all play a big role in what you can realistically achieve in any given project.
Okay, thank you. And Dave?
Yeah, Tess brings up some good points. Scalability, the size of your project is really going to affect what your expectations should be or how you're going to frame them. And the position in the landscape, how much do you control? Are you in the headwaters versus a lower, much larger streams? The larger the stream, the less control you have over conditions coming into the project. I mainly deal in very large watershed scale restoration projects, and you know, we emphasize a headwaters down approach. So the more you do in the headwaters, the more control, less risk. And I think to really have realistic expectations, you need to understand the underlying constraints of the project, so that the existing infrastructure, what's realistic to modify and not modify, your costs related to your funding, and having a good handle on what's causing the underlying degradation. It's not always obvious. It's not always directly relatable to landscape conditions, modern landscape conditions. That's all.
Okay, thank you. So we're going to proceed to the next question. How does stream restoration fit into a watershed management plan? And I'm going to start with Solange's answer, so forgive me for reading this, but this is actually an answer that she sent to me. So her comment was that headwater streams are particularly important at retaining nutrients, controlling the flow of water and sediments through the channel network, just as Dave was alluding to just now, both because they dominate the total stream length in a watershed. And actually, I mean, I calculated this for some watersheds. It's on the order of about 70% is the first and second order channels. And because they have a high land surface to water volume ratio, which is conducive to nutrient uptake and transformation and to diffusion of excess runoff. And she comments that she always finds that if headwater channels are degraded, there's a cascade effect in the entire drainage network. She did a literature review a couple of years ago looking at impacts of riparian forest restoration on biodiversity of macroinvertebrates and fish, and especially for fish. If the headwater streams were degraded, a lot of measures taken downstream just don't give the biological uplift. So her advice is you should always start from the top of the watershed down. Yet often stream restoration projects seeking to reduce pollutant loads don't necessarily target headwater streams. People don't think about them. Getting permits is complicated. There are other limiting factors, and that the system of TMDL credits makes it more difficult to think about headwater channels because the loads are larger in the downstream channels. And I'm just going to use one of her slides. She's done some work comparing headwater channels with downstream channels in terms of load reduction from nitrogen, phosphorus, and sediment. She finds a much tighter range of results in the headwater sites, and overall somewhat less success at the downstream sites. Part of it is for there's really a diversity of reasons involved, but a large part of it, I think, is what both Dave and Tess have alluded to. You can't control at the downstream end what's going on in the headwater part of the watershed. And this is a particularly severe problem in urban watersheds. We've all seen projects that have failed, not because necessarily the fault of the project, but because the watershed is so severely compromised that it's very hard to overcome the effect of the urban runoff coming from upstream. Okay, so I'm going to turn it over now to Scott and then to Tess to respond to this same question.
Tess, could you go quickly, real quick? And I have a household noise thing I have to deal with, and I should be done when you're done.
Okay, no problem. So to me, stream restoration should be, I think we can all agree that watershed management, or looking at the watershed as a whole, is definitely the most effective way to improve water quality. And so stream restoration is one of multiple tools that can be used to improve water quality and improve aquatic resources. But I think it really is important that it's part of the overall plan. And an example I will give is Strubles Creek, which runs under Blacksburg, under campus, and you saw the downstream end. And there was a TMDL impairment for aquatic life. The stressor was identified primarily as sediment, which is not at all uncommon. And then the source was identified primarily as stream banks. So for this particular watershed, reducing bank erosion was definitely the key way to achieve the overall watershed goals. But that was first identified as part of a watershed management plan. And we've definitely seen improvements, having gotten the cattle off the creek in the downstream end and in other places, restored the riparian area, pulled the stream banks back. And so, to me, it's really critical that stream restoration just be one of our tools, and that it's informed based on an overall view of the watershed.
Thank you. Scott, are you able to speak now?
Yeah, I'm gonna do my best. Sorry, there's a little background noise here.
And that's the world we're living in right now.
Yeah, I did move my dog and another meeting going on. I can't get too far from the Wi-Fi, so I know everyone can appreciate that. I really like thinking about the story component that Ike described earlier. We're really thinking about stream restoration as it relates to watershed plans as like a human health scenario, where the stream networks of our watersheds are like our circulatory system. And often there can be issues associated with the circulatory system itself, whether that's erosion issues like Tess mentioned, or head cuts that produce a tremendous amount of erosion in the upland interface into the stream network. But sometimes it's the outside impacts of urbanization or development or deforestation, or the historical issues that Dave mentioned before that are really the trauma that we're seeing. And sometimes those land use changes have to be modified or worked with as part of the process. I don't think there's a one-size-fits-all approach to whether or not it is required to have stormwater management in concert with stream restoration, but it's really a site-by-site, watershed-by-watershed evaluation. So whether or not you're treating the fitness and the health of the patient or a specific issue associated with a blockage in an artery, that's part of the watershed management plan and how the stream restoration strategies get selected.
I'm just going to add one thing to what Scott said, because I work some with Peter Goffman, who's one of the principal researchers in the Baltimore ecosystem study, and Peter's a biogeochemist by training, and he always likes to say that water quality monitoring is sort of like the urinalysis of the watershed. To diagnose whether there's a problem going on, oftentimes water quality, it's not just the problem, it's often the symptom as well. Okay, very good. So the last of the 5 questions is, how do you know whether it worked? How do you define success? How long does it take in order to know the answer? And again, I'm going to respond first with Solange's answer, and then I'm going to ask others to respond. And I think we'll have plenty of time to open it up for questions, but I think we'll also have time for everybody to sort of get a chance to deliver what they think is a takeaway message they want everybody to come away with. So Solange's answer to this question is that in general, stream restoration in the Chesapeake Bay area has multiple and often unclear goals, making it difficult to assess success and determine whether or not a project worked. Lacking clear goals also hinders our capacity to develop the most cost-effective monitoring an evaluation program. And she says that to overcome this problem, it would be helpful to first define restoration success by asking the following questions. Number one, what is the desired outcome of the restoration project? That is, what is the long-term goal? Number two, what are key measurable short-term goals necessary to achieve the desired long-term goal? And number three, what are some of the expected impacts? And those could be positive or negative. And she says, for example, a common main goal of stream restoration projects in urban catchments is measurable reduction of pollutant loads, nitrogen, phosphorus, and sediment most notably, exported to downstream waters. Short-term goals might be channel reconnection with the floodplain, reduced peak flows and erosion prevention. Expected impacts can include biological uplift, sustainability of the project in the long term, will it last, after 5, 10, 15 years, and perceived benefits to people, which often is something that may not be explicitly built into the goals, but you often see how people respond to things as being an important public measure of success. Negative impacts can be decreased riparian canopy cover. When we talk about adaptive management, all interested parties and stakeholders should be involved, and people's impressions and perceptions should be included. And she also points out that assessing the success of long-term goals and impacts may require monitoring for an extended period of time, which doesn't necessarily have to be continuous, but you do need to return after long enough to really have seen everything that can happen. And that's particularly true because you can get extreme events that can actually undermine much of what you have done over a period of time, and it's impossible to know whether you're going to survive an extreme event until one happens. So those are Solange's answers. I'm going to go ahead and turn to others to speak. I'll turn first to Tom.
Yeah, I like what Solange said. I'd kind of like to amplify some of that. But one thing that's tricky is to, in the case of where your goal is to try to meet TMDL expectations or guidelines, to be able to measure, how much total suspended solids and total nitrogen and total phosphorus are really coming through the stream, and whether or not the restoration did what you thought it was going to do or what you hoped it would do. And I think of the approaches as being divided into 3 categories. And the very best one is if you can measure what's going through the stream before the restoration. That's a really important piece of information to have. A lot of times we don't have that. The people come to restore a stream because it looks bad. It's deeply eroded. It's clearly that got a lot of bank erosion going on and a disconnection to the floodplain. So there's a problem there. But in order to really know how much total suspended solids and total nitrogen and total phosphorus reduction you get from your restoration, it's good to know what it was doing beforehand. And that's hard to achieve with given the way things work with permits and all of that, and getting somebody to pay for measuring something in a stream that hasn't been restored yet. Anyway, so if you can measure what happens before and after, then you can kind of tell what you've done most effectively. And also it helps to have an unmodified control to compare to the before and after. But that unmodified control can be the upstream part of the stream. Now, the kind of second best way to tell what a stream restoration is doing comes up where, as often happens, the restoration is already in place and then somebody wants to know what it did. So you don't have the luxury of measuring before. But if you look at the mass balance, the upstream, what's coming into the stream from upstream of the restored reach and what's leaving the reach through the outlet of the restored reach, to get a mass balance of the flow will give you some idea of what's being retained in the reach, or if the reach is a net source of something. The last choice is to compare watersheds that have different amounts of stream restoration and see if there's a correlation between the loads of nutrients and solids and the amount of restoration that's been done in the watershed. And this is you know, I think the kind of overview that's necessary, but it's also difficult to interpret if you don't know how it looked beforehand and so on. So that's all I had to say on that question.
So before I turn to Tess, I just want to point out, and maybe we'll get into this later, that that kind of monitoring for loads upstream and downstream, before and after, it involves money and it can involve substantial amounts of time. And so funding, getting the funding to actually have an ongoing monitoring program is often a major issue in terms of our ability to really interpret how well something works.
Yeah, and so that's good. I'm glad you brought up that point, Andy. And the thing is that it is expensive, and so you can't do it everywhere. But it's helpful to do it in some places so you can understand what's going on.
Okay, thank you. Tess.
I think Tom made some great points. I'll add to that. With stream restoration or anything dealing with non-point source pollution and water quality, and then monitoring those changes, most of the movement of these pollutants occurs during storm flows. And it's very tricky once the water gets out on the floodplain to actually measure how much water there is moving through there, and to also sample for nutrients and sediment. So I would second what Tom and Andy said. It's very time consuming and very expensive. And so we can't monitor that at every point. Also, depending on the length of your stream restoration, if it's a fairly short reach, the benefit may not be significant enough compared to the impacts. And again, thinking of stream restoration as just one piece in the puzzle to actually be able to even measure it. So but I also think about the success in terms of water quality as being one of the higher end goals. So I would say, how do you evaluate whether the project works? Well, that depends on your goal. And so if your goal is to prevent erosion around a sewer line or a road from being undermined, it's a very straightforward goal, and that's fairly easy to monitor. But as you start making the goals bigger and more complex, whether it's improving water quality or reestablishing an aquatic ecosystem, then it goes back to, is your goal even realistic, depending on the project? So how much of the watershed do you control? And can you even realistically achieve that? And so the length of time depends a lot on what your goal is as well. So a lot of the benefits we see, particularly with regard to bank erosion, are how long it takes vegetation to grow and become established is when we start to see benefits. If you're thinking about stream temperature and providing shade on the stream, well, now you're talking about a tree canopies reestablishing. So that may be 20 years or 30 years. And so I think it really just depends on, one, what was your goal? How do you measure it? And then what are the processes involved, and how long does it take those processes to reestablish?
Thank you. Dave.
Yeah, the interesting thing about this question is that there definitely is no right or wrong answer, or there are a multitude of right and wrong answers, I guess. I know in Pennsylvania, through our regulatory program, we've been working diligently to kind of transform our approach to stream compensation or restoration. The approach is used, we're moved away from a structure or form-based approach, which is, I guess, most akin to natural stream channel design, where you're controlling the planned form of the stream and trying to define every aspect of the riverine channel system, to a more process-based restoration approach, which is more interesting and more challenging, but I think addresses some of the long-term stability or dynamic issues with riverine environments. The one problem with that is there are really good tools for measuring performance and success yet, because it's a relatively newer technique, I think a couple decades now, and there's a paucity of research on it. from the effectiveness standpoint. So we're spending a great deal of energy right now to develop demonstration projects, and kind of as Tom alluded, we're looking at different types of studies with the projects that we have or the projects we're planning to demonstrate their success or how effective they are, and how fast that occurs or doesn't occur, the problems associated with the design approaches. Unfortunately, he's right that it takes a lot of funding, takes a lot of time, just to do a good job with one project in defining it, designing, funding, pre and post. You know, you're looking at almost 10 years, and not excluding construction, you're still talking about, you know, maybe $500,000 in funding just to do the monitoring work effort. You multiply that by the different approaches and the different places in the watershed that you want to look at, it gets extremely complex fast. So it's a tough question. I don't think there's any real right answers. I think one of the problems that we all are probably all encountering is the TMDL, especially related to Chesapeake Bay implementation. The TMDL and implementation plans aren't on the same scale as research and development. So the time scales are vastly different, and we're way behind the 8 ball to demonstrate changes or new techniques. It takes too long to demonstrate the effectiveness of a new restoration technique in relation to implementation planning, which is unfortunate. So that's about all I have.
Thank you. Actually, I'm going to ask Scott if he wants to respond to this, but before I do, I'm just going to point out that some of what Dave just said is part of the reason why the Chesapeake Bay Trust has an annual pooled monitoring forum for various presenters to talk about what they've learned about various kinds of projects. Some of the folks you see here today are going to be presenting there tomorrow, which is why our panel was scheduled for today. So I'm going to ask Scott if you have anything you want to say, having worked on a lot of projects and seen you know, what happens with them over time. Can you respond to this question?
Yeah, I mean, I think the points that are made are really pretty critical in that we don't necessarily have discrete connections in time and space between the impacts to the streams as well as the results of the restoration. And some of the research that's been done shows that there's increases in water quality downstream of a project. So sometimes the projects, similar to how you would think of stormwater management, have as much impact downstream as they do in the actual reach itself. But that's inconsistent and requires a lot of that research. And like Tess mentioned, which I think is pretty clear, most often how people are evaluating it is entirely visual. And I think that tied into the pictures that we've shown and how we've talked about it is the erosion reduction elements are relatively clear and the vegetation establishments are relatively clear. It's the deeper dive questions that are mentioned by Tom and Dave in particular, where it takes more time, and therefore picking projects that are fitting in a 5-year window for these permits that provide the maximum benefit, because we are stewards of the environment and stewards of public funding for this, is difficult. So that feedback loop is something that we're continually working and learning on. But there's a delay in how the restoration projects actually impact water quality, and there's a delay in how we learn about that and apply. But I think, like Andy mentioned, the pooled monitoring effort from the Chesapeake Bay Trust is a really critical step where all the stakeholders realize that more focused research is better than spread out research over small items on small projects. And efforts like that are really going to inform us and improve what we do moving forward. And I think that's a great effort by a great organization to help really improve all we do.
I'm going to add one comment of my own, and then I'm going to ask for about 5 minutes at most for if anybody has any last takeaway message they want to offer before we take about 10 minutes to answer questions. One of the things that you'll find if you read the literature, if you've tried to do any of this kind of work yourself, and it was alluded to earlier, is that the scale of the watershed and the percentage of the watershed you're actually able to control when you're trying to do some kind of restoration project has a lot of influence on what you might observe at the bottom end. In other words, the more of the watershed you can treat, it's pretty clear, the more likely you are to see a signal from the response to any improvements that you make. And so that's part of the argument that Solange makes. But even just trying to find a signal that you can show is statistically significant as the watershed scale gets larger and whatever you've done is a smaller percentage of that area, becomes harder and harder to detect it. Which then kind of raises a question, how do you figure out what's the ultimate value of what you're doing? And it's a difficult problem to resolve, which is why a fair amount of research is being done on this. I'll stop there and just ask, does anyone have any last takeaway? You don't all have to do this, but if anybody has a last takeaway point you want to make sure the audience takes away from this before we go to questions, this is your opportunity.
This is Dave. I did want to mention one thing that I forgot in my response to the last question. It's interesting, some of the work that we're looking at now in developing a demonstration project in the northern tier of Pennsylvania is how to activate watershed processes to passively restore riverine systems. So these are attempts to re-engage active erosion, which is what everybody's trying to stop. In these cases, we're actually looking to engaging the erosion process to aggrade portions of the watershed to reconnect floodplains passively, because you're talking about a scale that's, just not feasible to go in and actively rework the system. Or in this case, it's a national forest where the desire to take bulldozers in is not particularly high. So there's also this, active versus passive approach of trying to engage the processes to restore the system itself that we're interested in too.
I'd like to kind of follow up with what Dave just said, and that is that stream restoration is cited as a BMP, a best management practice, but streams are really ecosystems, and they're very dynamic, and we expect them to move. We expect stream channels to erode and aggrade and move around, and they're very dynamic, and I think that's important to keep in mind. They're not a stormwater pond. They're not a bioretention cell. It's an entire ecosystem. And so we want to see it change. That's important. And Dave has emphasized a lot, and I think that's important too, are the processes. Is how do we encourage these processes of sediment transport or aggradation, and erosion where it should be occurring as a natural process. And so trees falling in streams and those types of things are all, again, part of the process. And so that's really important that we think more in terms of process than seeing whether or not exactly what we built 20 years ago is still there. I think it's sometimes important to think about where we can. It's not always possible in highly urban areas to think about, nudging the system rather than forcing it. And then one last point, taking from Ike Irby's talk, which I thought was great. Urban stream restoration is really tough because, of course, people are involved very intimately, but there are also benefits beyond water quality and the ecosystem, the natural ecosystem. There's the human ecosystem, and so I think we should also incorporate the societal benefits. And he talked about parks, that I think a lot of the points he made about urban parks can also be made about urban stream restoration projects.
Thank you. Anybody else? You don't have to, only if you want to. I'm just going to make one last point. I think it is important to recognize that, we had that list where characterizing collectively all of the goals falling under the rubric of functional uplift. And you don't always get everything that you might want. And there are watersheds that are so severely impaired with not enough control, for example, what's coming from the headwaters, that you may not be able to achieve some of the goals you'd like to be able to achieve And sometimes you have to decide what are the things that you can actually can achieve. I know I've spoken with folks in the county agencies looking at particular streams and saying, you know, we're really not sure how we're going to accomplish some of this because of these severe problems in the headwaters. Sometimes the best you can hope for in some streams may be stabilization in something that looks somewhat natural, and you may not be able to restore all those ecosystem functions. And the fact is, sometimes we may be expecting more of stream restoration as a practice than we can rightly expect unless we're really treating the whole watershed. So I think it's important. That's the reason for this question about realistic expectations. So we've got about 10 minutes left. We already have a series of questions. I'm going to go through the questions that we've already got on the list, and we'll see who's best able to answer these. First one was from Michelle Kanek. I hope I pronounced that correctly. What scale are you thinking about when you say the watershed? Huck 12, 10, 8, etc. I think we're usually talking about fairly small watersheds in most cases, although Dave says he's worked with some pretty big ones. So anybody want to respond to that?
I agree. It's usually small watersheds that we're dealing with. And that kind of goes back to what Solange was saying, that maybe we should start with the headwaters.
Yeah, this is Dave. I think most, we look at probably the Huck 10 watershed, but we encourage, you know, all of our efforts are encouraged in less than 10 square mile drainage areas. We really look very critically at restoration proposals, at least from the permitting restoration side for offsetting permit impacts. We're not encouraging anybody to do restoration in streams bigger than 10 square miles. If they are, it has to be a complete watershed approach where they're doing work throughout that entire catchment, not just the main. We have had some projects in the 30 to 40 square mile drainage area, but that also involved all of their tributaries, all of the headwaters, you know, restoration of alluvial fans, etc. It was like all told, I think it's close to a 600 or 700 acre project for that watershed. So maybe like 35 square mile or 35 miles of stream, something like that.
Okay, the next question comes from Sandy Hertz. How do you reconcile the influence of outdated data inputs, for example, Atlas 14 intensity, duration, frequency curves, when you're designing your stream restoration, particularly in a highly urbanized watershed? It seems like at a federal level, there needs to be a push to review and compile more recent information from our stream gauge network to ensure that we have a more current understanding of the potential rainfall, frequency of storm events, et cetera, to ensure the long-term viability of these projects. And before I let anybody else answer, I will tell you that those efforts are ongoing. I'm involved with some folks that are doing some of this work. I believe we have at least one talk somewhere in this symposium, I think by John Butcher, who's working on a revision of IDF curves. And their federal agencies are actually working on updating flood frequency analyses to incorporate non-stationarity as well. But does anybody else have anything to say to add to that?
I can just say when we're reviewing design plans, we focus more on shear stress than we do storm interval and the discharge. So we're looking at can the floodplain and the stream channel system handle the shear stress, which is a combination of the flood and the physical depth of the water and the extent of the flooding and the configuration of the floodplain and roughness. I've as a biologist, that's where I finally gotten interested in hydraulics. It actually provides some useful or visual information for me to evaluate versus a table of numbers. I've found it extremely useful, and it's been very effective to this point.
Okay.
And I agree that the work from NOAA and USGS in particular is really critical to the projects. And specifically looking at hydrographs is kind of an underutilized effort as far as the determination. You know, we're used to using depth slope product as the primary driver for shear stress, like Dave mentioned, but often we're finding the onsets of these storm events where they have any sort of flood wave situation can accelerate or increase the values associated with evaluating the hydraulic properties of a particular stream reach. And those things are understood to a lesser degree and really need more research and support. I know Andy, that's near and dear to Andy, so I feel like I'm answering on his behalf too.
That's just fine. Anything that talks about this is always to my, I appreciate. I'm going to move on because we have a few minutes left and hopefully we can get through these questions. Andrew Lazur says, Tom's point on the importance of measuring water quality prior to restoration is fundamental and critical, especially in demonstrating impact and telling more of the story of the research that like Irby mentioned. I don't know if that requires a response or if that's just an affirmation of what you had to say.
It sounded like an affirmation.
Okay. And Kathy Boomer says, I'd like to follow up on Solange's and Tom's emphasis regarding the importance of location to restoration performance, but also acknowledge the influence of seasonal and interannual weather patterns, in addition to habitat conditions. These realities create challenges to evaluating whether a project is successful or not, and also to extrapolating data across a broader landscape. Could the science community provide more meaningful information by, one, better connecting field observations to spatially explicit model predictions, and two, communicating how and whether the results improve our confidence in our understanding of system behavior? And I'll just say that is a fairly high level thing to ask for. I think it's certainly something the research community is interested in. Does anybody else want to respond?
Oh, the last part of her question, I think, is referring to like, what are the uncertainties of our measurements? And I think that's really important in deciding what kind of management practices we want to use, not just what the expected performance is, but the uncertainties of our expectations. It's kind of like investing in the stock market. You want to know, how certain you're, or what the confidence is in your investment, not just how much money you might make.
This is something I've heard discussions of at pooled monitoring forum meetings. I'd have to go back and look and see whether any of those kinds of discussions tomorrow. Tess is doing an evaluation of a bunch of projects, and I don't remember what you're talking about tomorrow, but I don't want to take people away from this meeting, but for those who are focusing on this professionally, there may be some discussion there as well. Does anybody else want to respond?
Yeah, I was going to say something, of course, with streams, we're dealing with processes that occur over much larger time spans than our lives. If you're talking about sediment transport and, those geologic processes, and then, you overlay these really long-term processes with the variability of weather, which is driving, of course, the hydrology. And it gets really complicated really fast. And as an engineer, our traditional approach is to apply a factor of safety. If your bridge pier is a foot wide, you make it 2 feet wide. Well, you can't do that with an ecosystem. And so I think finding the balance, the models can help us extrapolate what we see in the short term to then understand longer term, to really look at the processes that occur longer term. So I think, there is an important need for modeling with the appreciation that, yeah, there's definitely error and uncertainty in there. But whenever you work with streams, you're working not with just the short term type of situation. You're dealing with something that frequently is responding, say, to something that happened 300 years ago, if you're talking about legacy sediments.
I'll just augment that and say on behalf of STAC that a lot of what STAC is engaged in right now is trying to figure out ways to use what we know about uncertainty to constrain our understanding of what the possible impacts are of different approaches. We can't ever do away with uncertainty. We have to figure out how to live with it and work with it. So there's 2 comments left here. One from, well, 3. Sandy Hertz is simply agreeing uncertainty is important. I'm going to go to one that doesn't have a time on it, but was actually asked earlier. That was from Stephanie Scholler. Ooze. I'm not sure if I'm pronouncing that correctly. In addition to TMDL, are you working on anything to reduce plastic pollution? Does anybody actually deal with that question when it comes to restoration?
Not just from a general sense of trash being in some of our larger urban projects where we have to we have to address using hydraulics or using the flood and floodplain configuration to eliminate floatables or to get them to deposit out in certain areas, use plants to screen them or sieve them out passively. That's just from that perspective.
Scott, did you
I
have a
mean,
hand raised? I'm sorry.
Yeah,
Yeah.
that's been my same experience too. Sorry, Tess, is that
Oh.
people are utilizing hydraulic elements of a design to try to partition an area where floatables can be trapped and then later removed.
So I think we're just about out of time, and there are a few questions that have come in at the last couple of minutes that I don't think we're going to have time to answer. I don't know whether our panelists can respond to them. There's one from Bill Ball, one from Lauren McPhillips, one from Grace Chu, but I have a feeling we're going to have to yield the screen at this point, unless Raleigh tells me otherwise. Scott said there was a question in the chat column about comparing regenerative stormwater conveyance to conventional stream design. I'm afraid we've run out of time, and I missed seeing that because it was in the chat window. So we'll have to probably answer that offline. And I'm going to thank everybody at this point and yield the screen so that Raleigh can take back over again. And the answers we didn't get a chance to answer, we'll try to deal with offline. So thanks everybody for your participation.
Great, thank you very much.
Thank you.
Andy, I'm sure everybody else is clapping. Thank you, panelists. That was a really interesting discussion.
How do I give up? I'm trying to figure out how to stop sharing the screen.
I don't know. Thank you so much. And so just before we go to break, which we're going to do in just a couple of minutes, I'd like to go ahead and announce the 2020, the name of the recipient of the 2020 Guardian Award. But the CCMP steering committee decided not to do the formal presentation of the award this year in a virtual format. We decided to wait until 2022 to do it in person. We just thought that was a better way to handle the award than doing it virtually. But I would like to just read from the solicitation for nominations, remind you of what the award is about, and then I'll announce the awardee. And so in terms of background, the Sellner Chesapeake Guardian Award was first presented to Dr. Kevin Sellner at the 2014 Chesapeake Modeling Symposium for exceptional service dedicated to the advancement of community modeling in the Chesapeake Bay region. The CCMP has established this award in Dr. Sellner's honor in appreciation for his more than 30 years of research guidance